Hi, welcome to our presentation on factory patterns, presented by John Bake and Steve Milton. Factory patterns are one of the subsets of creational patterns. These patterns utilize abstract classes for object creation. Generally, when one object needs to instantiate another object, a dependency is created between the two. They are coupled. Thus, if the second object is changed, the first object must also change and be recompiled. Creational patterns use encapsulation to decouple object creation. We will discuss both the factory method and abstract factory patterns. First, let's talk about the factory method pattern. We know from studying object-oriented design that decoupling can be achieved by using an abstract base class as an interface between the two objects. Essentially, the interface contains the specifications needed by the first object, but the implementation of those specifications is handled by the derived child class of the interface. This results in removing the dependency between the two objects. The factory method uses this concept of abstract interfaces to further encapsulate object creation. In its most simple form, two abstract base classes are used. We first create an abstract class called a factory that has a derived concrete factory class. It is this class that actually handles the creation of the needed second object. The second object is also derived from an abstract interface class, completely insulating object 1 from object 2. Because of this, changes can be made to the second object without impacting the first. This also gives us the capability of creating multiple objects with different interfaces using the same factory class. For instance, this pattern could be used by banking software to create different account types. There could be an abstract interface for a savings account and one for a checking account. A second abstract base class then functions as an interface for a concrete factory class that creates the account objects. The process of account creation is maintained by the factory, while the specifics of the account type are maintained by each of the two account type interfaces. The abstract factory pattern is an additional pattern that builds upon the factory method to create an additional layer of abstraction. Now we have an abstract factory class that functions as an interface for multiple concrete factories, in essence a factory of factories. Each concrete factory contains the specifications for different creation processes, allowing us to now have object 1 contain references to distinct objects that are created with distinct processes. To extend our analogy, we could now have both different account types, but also different services like loans that can be instantiated from one single object without creating dependencies between the objects. So it would seem advantageous to use factory patterns in many applications. The patterns allow objects to be decoupled so that the application is less bug-prone. Using abstract interfaces in this way also maintains consistency in object creation. Extending the instantiation process to further classes becomes easier too. The use of inheritance in the pattern also allows greater flexibility at compile time, and this flexibility is further enhanced through object composition. However, there are also a few disadvantages to factory patterns. Primarily, this method increases the complexity by requiring more subclasses to create the desired encapsulation. Anytime complexity is increased, performance will decrease to some extent. While these patterns do result in less compiling due to the lack of dependencies, the additional amount of code and processes may offset this performance gain. Now that we understand the advantages and disadvantages, we can better determine when to use factory patterns. Applications that will require multiple families of classes or objects for use by one object are a prime candidate for these patterns. When we have a stable object that requires an unstable object, the factory method pattern may be applicable. In other words, if one object requires a second object that we know will be complex to develop, decoupling the two will result in fewer bugs as we work on the implementation of the second one. Finally, when we have utilized the factory method, but realize we need to extend that to multiple families of classes, using the abstract factory pattern may be desirable. Let's take a look at how this type of pattern could be used on the Grad Planner project. One common use of factory patterns is in providing elements of an interface in multiple styles. One option would be to allow the user to choose the style of interface used to view the Grad Planner. In this case, there would be an interface object that would need to instantiate objects from an interface elements class. Using factory patterns, we would create an abstract factory that would have concrete factory-derived classes for creating element objects in different styles, such as Windows or OS X. The objects would be derived from different interfaces for each element type. For instance, there would be an abstract button class, drop-down arrow class, and so on. These classes would be utilized by the applicable concrete factory to create each element for the interface. Another way factory patterns could be used is in the creation of plans. The MyPlans object would need to reference one or more plan objects. These objects could be created using an abstract factory and derived concrete factory to control the creation of each plan. The plan objects would derive from the abstract plan interface. There are likely other opportunities to extend the use of the factory patterns in this product as well. In summary, factory patterns are a type of creational pattern designed to improve the encapsulation of object creation. This is accomplished by using abstract classes to create interfaces between objects and the objects they need to instantiate. This removes the dependencies between objects and allows multiple object types to be created using one interface. The factory method can be extended by adding another layer of abstraction to provide for the creation of multiple factory types. This is called the abstract factory pattern. Use of these patterns can make an application more reliable and flexible, while also allowing it to be more easily updated for use with additional families of classes. However, this may come at a cost of increased code complexity and decreased performance. The factory patterns should be used in instances where many related objects need to be created by another object. It is also a good choice for situations when it is important for objects to be decoupled. Thank you for viewing.